Hello, Honors Chem students. This is Mr. Keister here with you again. This is the video for Thursday, September 10th, 2020, which is our scheduled 15th day of school for the fall semester. Always keep in mind, however, that the dates could change for a variety of reasons, but the order of the lessons will always remain the same. So let's look at the do-nows and see what today's schedule is. So today you are to pick up Lab Activity 1-2 Density Part C, which is penny density, which is page 25. Yesterday, of course, we worked on Part B. We did quite a bit of it in class, and I assigned you some as homework for today. So, as I just said, Part B I had you finish for today. Hang on to that. Please check your answers. I did not collect it. They are posted on the back board as of 7 a.m. this morning, and they are also posted on the answer keys page in Canvas, which of course you can access from my homepage. Make sure you're doing everything correctly. Had you do some density, little density calculations and or some graphical analysis of density, and I'm going to go over just a little bit of that here before we get started on our lab activity. So this lab activity with penny density today is due tomorrow, and I will be collecting that one for a grade. I will be. So let me grab Part B real quick. And yesterday we went over, let's see, I had you start. We did parts 3A and 3B, and I did the first one in part C over lead. You were to do nickel and zinc. Again, you could have solved the density mathematically by using D equals M over V. You could have also solved for mass by doing it graphically, by looking at your graph. Remember, we dealt with a volume of 8.00 or 8 mLs, and you could have graphically analyzed the mass of nickel and zinc from those. Now, keep in mind, graphically, it's not going to be as accurate nor as precise as it is by doing it mathematically, but either way would have been fine. I like question 4. Standard backpack is approximately 30.0 centimeters by 30.0 centimeters by 40.0 centimeters. Suppose you find a hidden treasure of pure gold while hunting in the wilderness. Wouldn't that be nice? In part A, it asks you what mass would your backpack hold if you filled it with gold. So the density of gold was given as 19.30 grams per ml. So remembering that D equals M over V, and you're given D, you needed to find V first. And they gave you the dimensions of the backpack. So volume is length times width times height. You would have multiplied those out into the correct number of significant figures, which was 3. The answer in long form was 36,000 centimeters cubed. But there's really no way to express that to 3 sig figs in regular format. That's only 2, and if you put a decimal point at the end of the last zero, it would have been 5 sig figs, which is too many. So I put it in scientific notation, which is always an option, and listed it as 3.60 times 10 to the 4th centimeters cubed, or mLs, of course. And then plugging that in for V and solving for M, I got an answer of 695,000 grams. Again, to 3 sig figs, 695,000 grams. And then in part B, it asks you to change grams to pounds, given there's 454 grams in 1 pound. And so if you take 695,000 grams and divide it by 454, you get 1,530 pounds, again, to 3 sig figs. Think about that. There's 2,000 pounds in a ton. This is over 1,500 pounds. Friends, this is 3/4 of a ton. 3/4 of a ton, the gold that would fit in a standard backpack. Gold is quite dense. Letter C, would you be able to carry this gold-filled backpack on your hike? Unless you can lift 3/4 of a ton, the answer is no. All right, but listen, at about $1,300 an ounce, and that's the last time I checked, it might be a little more than that now, that 3/4 of a ton of gold is worth almost $32 million. So somehow, some way, I am getting that gold out of the wilderness. Trust me, I'll get it. All right. So anyway, I like that question. It's a great density question. Just shows you how dense gold is. It's very, very dense and very valuable, of course. So let's move on to today's. Okay, so I'll bring the screen up here. So this has to do with the density of pennies. And we're graphically going to determine and compare the density of two sets of pennies. Penny set A was minted before 1982, all right? Penny set B was minted after. All right, in 1982, the U.S. Mint changed the composition of pennies. Before 82, they were made entirely of copper, all right? So, pure copper, 82 and older, all right? In 82, why do you think they changed it? Well, copper was getting more expensive. Of course, as we use it up, it becomes more valuable. It is not an unlimited resource. It's non-renewable. And so as we start using up all this copper, of course, its value increases. Well, it got to a point in 82 where it said the federal government said, well, this is ridiculous. It's costing us more than a penny to make a penny out of pure copper, so let's change it. So in 82, the mint changed the composition of pennies to mostly zinc, all right, with a thin copper coating on the outside. So they look the same size, the volume is the same, but the densities are different. All right, if you recall from lab activity 1-2A, where we compared the densities of copper and zinc, copper is significantly more dense than zinc. I think you'd have to look it up. Let's see what I have. Yeah, copper's density was 8.96 grams per ml or grams per centimeter cube, and zinc was 7.13. So copper's more dense. So basically, if the volume's the same and the density of the current pennies are less, then they're going to be lighter. Right? They're going to be lighter. So less mass, of course. So anyway, the question, so now let's zoom forward to 2020. Well, we're in a dilemma again, all right? Because, in fact, they've been talking about this for several years. They're talking about phasing pennies out altogether. And we're right back to where we were in 1982. Even making pennies out of zinc, which at the time was a lot cheaper than copper, and plentiful. Zinc's very plentiful. We have large reserves of it under the ground in this country. So then it made a lot of sense to make pennies out of zinc. We weren't losing money doing that, but now that situation has changed. So now we're right back to where we were in 82, where pennies are costing more than a penny to make, and times being are what they are. It just so the debate rages on: are we going to dump pennies or aren't we? So that remains to be seen. We'll see. So there are some questions here for you to answer as part of the lab report, and I will leave those to you. So let's head back to the lab area and get with the experiment. So let me unplug here, and we'll head back. Okay. Set this up right here. See what we're doing there. There we go. All right. So what we have, if you look at the data table with me, we're going to find the mass and volume of different numbers of pennies, both pre-82 and post-82. So we have a set of pennies here that were minted before 1982. These, of course, were pure copper. And then we have a set of pennies, set B, which were minted after 1982, which are, again, mostly zinc, with just a thin copper coating on the outside, so they look the same. But again, the pennies are the same volume. They're the same size. The size hasn't changed at all. Got to fit in the slots, you know. All right, so we are going to find the mass and volume of various numbers of pennies. If you look at the first line there, it says 0. Remember, when we're graphing mass versus volume, 0, 0 is a valid point, so we can just fill those in right now. That first line would be 0 grams, 0 mLs, and then again for set B, same thing, 0 grams, 0 mLs. Then we're going to find the mass of 1, 2, 3, 5, 7, 9, and 13 pennies of each type, and then we're going to find their volumes. Again, I'm going to find the masses first because we're going to have to find the volumes by water displacement, and I don't want to be finding the mass of pennies that could be wet. Even if you dry them off, there's probably still some water on them that will affect the mass. We don't want to do that. So we'll do all the masses first, and then we'll come back and do volumes. So let's take a look here at the pre-82s first. Got them right here. And of course, we've already filled in the first line, which is 0 grams. So 1 penny. So I'm going to go right down the far left column. We'll get the masses of the set A pre-82s. 1 penny is 3.08 grams. 3.08. 2 pennies, 6.21 grams. 6.21. 3 pennies, 9.26 grams. 9.26. Then I need to add 2 more. We need 5 now. 5 pennies, 15.37 grams. 15.37. And then 2 more gets us to 7. 7 pennies, 21.51 grams. 21.51. 2 more gets us to 9. 27.63 grams. 27.63, and then 4 more, which gets us to 13, is 39.94 grams. 39.94. So there are the masses of our pennies for set A pre-82. Now we'll do the volume. So I'm going to need some water. See how many pennies that is. So I'm going to need at least about 12 or so mLs of water. I'm going to probably go a little more than that just to be safe. See if I can stop it on a line here. That'd be nice. Oh, not bad. All right. Well, I stopped it right on 20, but again, smallest marking's the ones place, so we got to go a decimal to the tenths. So 20.0 would be my volume I'm going to work off of. All right, so now I'm going to add 1 penny. Oops. I'm going to add 1 penny here. And it went up about 0.5 ml. So let's go 0.5 mLs for 1 penny. I'm going to add a second. Not surprisingly, it went up a full ml, so now we're at 1.0 mLs for 2 pennies. Third penny, well, didn't go up all that much. I'd say that's between 1 and 2, but not really halfway. I'd say 1.2 mLs for 3 pennies. Now we're going to 5, so I'll add 2 more. 1, 2. Try not to splash any water out. Don't want any air there. 5 pennies. Looks like we're going right up about 2 mLs, so 2.0 mLs for 5. Need to add 2 more to get us to 7. Okay, I'd say we're right at about 2.5 mLs. Yeah, it's about halfway between. 2.5. And then 2 more to get us to 9 pennies. And now we are sitting right at about 3.0 mLs volume. So I originally started with 20.0, and then I just gone up from there. So it makes it pretty easy to read since I started on a whole number that ended with 0. So anyway, 9 pennies was 3.0 mLs, and finally I'll put the last 4 in to get us to 13. And we are now at 24.5, so that would be 4.5 mLs for 13 pennies volume. Okay, so we got all the masses and all the volumes of our pre-82 pennies, which were set A. Now we'll do set B. I'm going to go ahead and get my volume set up here again. Got the pennies drying. All right, I'm right at 20 again. So 20.0 will be my starting point, just like it was the first time. All right, well, let's find the masses first of our newer pennies, those minted after 82. All right. So again, same size as the original, so the volume is the same. The volume of the penny itself is the same. So let's do the mass. Of course, we've already got 0. So 1 penny, 2.48 grams. Okay, this shouldn't be a surprise. So look back at 1 penny of the pre-82s. It was 3.08 grams. A penny now at post-82 is only 2.48 grams, which makes sense. If the pennies had the same volume and the zinc pennies, which these are, mostly zinc, are less dense than the copper pennies, the older ones, then the mass should be less. All right? So 2.48 grams for 1. 2 pennies takes us to 5.03 grams, 5.03. 3 pennies, the mass is 7.55 grams. As I look over at set A, 3 was 9.26 grams. Now we're only at 7.55. Add 2 more to get us to 5. 5 pennies, 12.56 grams, 12.56. 7 pennies, 17.56 grams for 7, 17.56. 9 pennies, 22.56 grams, 22.56, and finally the last 4 gets us to 13. 32.63 grams, 32.63. Now, we're going to check the volume of each of those pennies. Now, I just said the volume of the pennies really hasn't changed. So, I mean, theoretically, the volumes in this column should be the same or nearly the same as they were before. But keep in mind, reading a manual device certainly has its subjectivity. So maybe it'll come out the same and maybe it'll be close. But either way, we'll go with what we got. So start with 1 penny. I'm starting right on 20.0. And once again, it's gone to 20.5. So the volume of 1 penny is 0.5 mLs. Get the second one in there. And it's gone up to 21. So 21.0 minus 20.0, 1.0 mLs for 2 pennies. So far, so good. 3 pennies. There again, about 1.2 mLs. It's kind of in between 0.2 and 0.3, but it's not quite halfway. So I'm going to go with 0.2. So far, I'm right on from the last time, which is good. I was kind of hoping it turned out that way, but you never know. Error, right? Always error in measurement. Now we're going to 5 pennies. So I'll add 2 more. And now we are up to 2.0 mLs. All right, 2.0. Two more get us to 7. 2.5, halfway in between those two. So 2.5 mLs. Two more get us to 9. Volume of 9 pennies. Once again, we're right at 3.0 mLs. Geez, I'm so far so good. Let's get the last 4 in there to 13 and see if we can close this baby out. Well, you know what? To me, that looks like about 24.5, and we start at 20.0. So I'm going to say 4.5 mLs again. Let me scan through. Man, they came out the same. Gotta love that. Yours may or may not do that exactly, but again, the volumes of the pennies really didn't change. Only the densities did, and thus the mass did. So hopefully they do come out the same both times, but even if they're off a little bit, that's certainly understandable due to measuring error. So let me get these drying. Okay, let's turn the page now. Number 1 says, using the attached graph paper, you're going to plot the data points for both sets of data and draw a best fit line. Remember what a best fit line is. It's not a connect the dots, all right? It's not a zigzag line. It's a straight line, as the name implies. Incorporating as many of your data points as possible. And those that can't be incorporated, get them as close as you can. Remember, too, that 0, 0 is a valid point for any mass versus volume graph, and so your graph of both lines, both densities, should run to the origin, okay? So it asks you to label that and then determine the slope of each line, which is the density of those pennies. And remember, you only need 2 points to determine slope, and you can use 0, 0 as one of those points. So just pick any other point that's on your line for each line and go from there, and you should be able to fairly easily determine density. So let me I'm going to show you real quick when I graphed my data. And so I did it in 2 colors so it'd show it better. You don't have to do that. But again, I just wanted you to see in general that I ran both lines to the origin, which you should. And then I incorporated as many of the points on there as I could through a best fit line, and then calculated the slope of each line. Okay? So based on that, then, you are to answer questions 2 through 7. Okay? Don't forget to answer the questions on the front page, all right, as well. And make sure your graph, again, is properly labeled and all the work that I asked for is on there. And this will be due tomorrow, okay? This will be due tomorrow. So that takes care of Lab Activity 1-2 Part C, the density of pennies. Until next time, this is Mr. Keister signing off. Until then, keep working hard, stay safe, and I'll catch you next time. Got to wave goodbye, See you guys later.